Hi, it's Mr. Anderson, and in this video I'm going to be discussing the properties of water. Alright, so let's start by looking at the chemical composition of water. And basically it's made up of 2 hydrogen atoms and 1 oxygen atom. And what you should know is that oxygen is highly electronegative. And what does that mean? It means it's going to pull electrons towards it. And if we were to look at the levels here on the periodic table, aside from fluorine, it's going to be the highest one here. And so why is that? It's because as we go across the periodic table here, it's going to increase in electronegativity. And again, why is that? Why is that? We're increasing the number of protons in the nucleus. And therefore, there's a more positive charge on the inside as it pulls the electrons towards it. And due to this nature, water is going to have its electrons shared unequally at the poles, or it is a polar molecule. And so what you get is a slightly positive and a slightly negative charge. And in other words, oxygen is going to be slightly negative, while the hydrogen is going to be slightly positive, as seen here. And what you get here is almost like a little magnet. There's just a negative portion and a positive portion, so they connect. And from this is known as hydrogen bonding. And hydrogen bonding is simulated by these dotted lines. And as you can see, the slightly negative portion of the oxygen is attracting the slightly positive portion of the hydrogen. And from this hydrogen bonding, we can it demonstrates the cohesive properties of water. And so a little analogy here: if I were to take my hand, this is a water molecule, these are the 2 positive portions, hydrogen portions, and if I take another one, obviously water is going to connect here where the oxygen is. And if I were to pull my hand away like this, you can see it's kind of going to guide my other hand through. And that's basically cohesion. And with this, it also creates surface tension here. And this is because, again, with my hands, the hydrogen bond, it doesn't want to break this bond here. So it creates that property of surface tension. Alright, moving on. Another property of water is the capillary action, or adhesion. And so what's capillary action? Basically, through this graduated cylinder here, you notice that you see water just kind of creeping up on the sides of the graduated cylinder. And at the bottom of this is known as the meniscus. And this demonstrates the adhesive property of water because it's binding to the edges of the container. And it also demonstrates cohesion because the water is following the water molecules connecting to the end of the container. And another thing is, if we made the graduated cylinder skinnier, you'll notice that the meniscus would be lower and it would go even higher. And if we made this at a microscopic level, as in the xylem in trees, in combination with adhesion, cohesion, and the energy from the sun, it will allow water to reach the ends of the leaves. Okay, so moving on. Another property of water is its very high specific heat. And basically what it means is it takes a lot of energy to raise or lower the temperature of water. And so a perfect example of this is like this summer, when we go to the beach in the middle of summer, it's going to just be super hot outside, just ridiculously hot, 95 degrees. But you'll notice that the water is pretty cold. And this is because of the high specific heat. And the water is cold because even though it's hot outside, it takes a lot of energy to change the temperature of the very large amount of water. And another example is, since you've probably heard that we live in a desert, and it's true, But the reason why it's not so ridiculously hot here is because of this high specific heat. The large amounts of heat California gets is absorbed by this water. And tying onto this is the heat of vaporization, and it basically explains that it takes a lot of energy to vaporize water into the gaseous state because of the hydrogen bonds. Again, water does not want to break this bond here, so it's a very strong bond, and it takes a lot of energy to break this so that they're free. Another thing is that it's a universal solvent. It's very good at dissolving hydrophilic, polar, and ionic solutions, or solutes, and substances that have an affinity for water. However, it doesn't dissolve hydrophobic, nonpolar solutes, or substances that do not have an affinity for water, such as cell membranes and oil. And in general, it's like dissolves like, or polar dissolves polar, and nonpolar dissolves nonpolar. And this is basically because, again, with this, if for example this was completely equal, it had no water has no way to connect to this because it's completely equal. So there's no negative portion for water to dissolve to. So that's basically why. Another unique property is that ice doesn't sink. And water is one of the very few substances that to weigh less in the solid state. And this is due to water's unique crystalline lattice. And when it freezes, this lattice allows it to expand, therefore lessening its density. And why is this really important? It's really important because all bodies of water would freeze over and all life would die. And since water freezes on the surface, it insulates the water beneath and allows life to survive in the winter when the lakes are frozen over. So really, water is really an amazing molecule, and it allows life to really exist on our planet. And as we start to look for life out in the universe, what do we look for? We look for water. And one of our most prominent candidates right now is Jupiter's moon, Europa. Although we're suspecting that due to its ice outer shell, that water will be beneath, and with this water will come life due to its very unique properties. And so that's water. It's polar, it's amazing, and I hope that's helpful.